Okay, welcome back. So today we're going to continue looking at some more probability, and we're going to be looking at events that are compound or contain multiple types of outcomes inside them. So let's look at our first one, 1A. So a bag contains 2 yellow, 5 black, and 3 white counters. Find the probability of yellow or black, so Y or B. Now, this can be considered an inclusive OR. So an inclusive OR means that I am happy with a favorable outcome if it is either yellow or black. It can be either. So both of those will be favorable outcomes. So because we have 5 black and then we have 2 yellow, that means that there are 7 favorable outcomes out of a total of 2 plus 5 plus 3, which is 10 total outcomes. Alright? When it says this or that, it's happy with either event. Alright. What's the probability of not white? Right, so not white, we are looking at the complement. Okay? If we look at the sample space of this particular chance experiment, we have yellow, and we have yellow, and we have black, 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 and then white, white, and white. And that's the entire sample space. That's all the things that we can pull out of the bag. So when we are talking about not white, well, here's white, these 3 here. So not white is all of the rest. Okay? So that means 7 out of 10 again, because only 3 of the 10 are going to be white. Find the probability of yellow or white. Well, the probability that it's yellow or that it's white is going to be ones where you're satisfied with it either being yellows or whites here. That means that there are 5 total favorable outcomes out of a possible 10 total outcomes. That's 5 out of 10, which simplifies down to a half. Okay, lastly, give an example of an event from this bag that has a probability of 0. That means it can't possibly occur, it is completely impossible. So we could write something like the probability of blue. Because there's no blue counters, we know that its probability is going to be 0 out of 10, which is just 0. Okay, here's another one. So we have a spinner again. The weird Wheel of Fortune, except this one's broken up into 10 equal sections, alright? So it's broken up into a few equal sections. Just imagine that the ones I am currently drawing are going to be equal. Here we go. Just a purely beautiful wheel we've created. And they're all numbered. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Right, so we spin the wheel, we land on one of the numbers, and in our first one it's asking for the probability that it's a multiple of 2. Okay, first things first, how many multiples of 2 are there? Well, let's have a look at the sample space. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And if we see here 2, 4, 6, 8, and 10, those 5 are multiples of 2. So this has a probability of occurring of 5 out of 10, which is equal to a half. If we look at B, probability of a multiple of 5. Right, so what here is the multiple of 5? Well, 5 is a multiple of 5, 5 times 1, and 10 is a multiple of 5, 5 times 2. So there are 2 favorable outcomes out of a total of 10 outcomes. You can simplify this again to a fifth if you would like. Alright, let's look at the next one. So for our next one, we have C, which is find the probability that it's either a multiple of 2 or 5. The probability that's an M of 2 or 5. Okay, so let's look at what this means. It means that we will take either scenario, whether it is 2 or whether it is a multiple of 5. That means we'll take 2, 4, 6, 8 and 10, or we'll take 5 and 10. Now, because 10 occurs in both sets, we can't use it twice. So that means that we can't simply add the probability of finding a multiple of 2 and the probability of finding a multiple of 5 together, because there's some values that intersect, right? So the sample space for this question would look like this. It would be 2, 4, 5, 6, 8, and then it would be 10. So it would be all of these values, but in addition to the even or multiple of 2 values, we have this extra 5, right? So it's basically all the set multiple 2, but adding in that 5. So that's going to be 6 out of 10. Alright, lastly, let's do D. So find a multiple, find the probability of the multiple of 2 and a multiple of 5. 2 and 5. Okay, so multiple. Multiple of 2 and 5. When we have AND, it's different to OR. These are very different. The OR means any multiples of 2 or any multiples of 5. The AND means it has to have both of these qualities at the same time. So it has to be a multiple of 2 and a multiple of 5. If we look at the sample space, there is only one value that is both a multiple of 2 and a multiple of 5, which is 10. And that means that the probability of this occurring is 1 out of 10. Okay, so for this last one that we're going to do, we're just going to talk quickly that in probability, just in general, we use a lot of questions that involve playing cards, or cards involved in the game of poker or other things like that. And they are a set of 52 cards, 4 different suits, 13 cards in each, right? So you kind of need to know a little bit about cards when you're answering these questions. So here are the 4 suits here. You have your hearts, your spades, your clubs, and your diamonds. So in each of these, you each have an ace, a 2, a 3, a 4, a 5, a 6, 7, an 8, a 9, a 10, and a jack, and a queen, and a king. Every single one of these have exactly the same cards, which means that there's 4 of each card in the total set of cards. Now, given that information, we can now answer the first question. So 3A is asking that a card is drawn from a standard 52 deck. So randomly we pull out a card. What is the probability that it's a king or a spade? Right, so probability, king or spade. Okay, so we know in the spades, which is here, there are 13 cards. There are also 13 cards here and 13 cards here. And of those 13 cards, each one of these has a king. We have a king of hearts, a king of spades, a king of clubs, and a king of diamonds. Alright, so when it's asking what the probability of getting a king or a spade is, you might think, oh, it's going to be the probability of getting these 4 kings against the probability of getting these 13 other values. And the reason why it's not that is because if you see this point here where I've selected where they intersect, if we're going to, oh sorry, spades is up here, if we're going to say that it's going to be all of these values, then we have to recognize that a king of spades is a spade. So we can't say ultimately that there is going to be 13 plus 4 because one of the 13 cards is this king of spades. So the total number of favorable outcomes is going to be the 13 spades cards, including the king of spades, and the 3 other kings. So it's going to be 16 out of 52. And the reason it's not is because the king of spades, the reason why it's not simply the probability of king plus the probability of a spade, so the king of spades is in both sets. Alright, if we said that there was in fact 13 plus 4 over 52, then we would be altering the probability and suggesting that there was another separate king of spades. Alright, that's it for this video. Hopefully it was helpful, and I will see you in the next one.